Now, in this video, we will go to take up one more problem on the temperature stresses on taper bar now. So to do that, first we'll go for the problem. Problem number 64, it reads as an aluminium bar tapers from a diameter of 200 at one end. So that is the diameter of 200 mm at one end. 200 mm at the other end. So 100 mm at the other end over a length of 100 mm, 1000 mm. The bar is stress-free at a temperature of 27 degrees centigrade. So there is no stress at the temperature of 27 degrees centigrade. If the temperature drops at 0 degrees centigrade, find the maximum normal stress on the bar if the ends are attached to the rigid support. Take Young's modulus of aluminium bar as 0.7 into 10 to the power of 5 Newton per mm square, and alpha A, that is aluminium coefficient of thermal expansion of aluminium, is 24 into 10 to the power of minus 6 per degree centigrade is the value. So now, what is the temperature drop? Temperature drop is 27 minus 0, which will be equal to 27 degrees centigrade. Elongation of taper bar of circular cross section delta L is equal to 4 into P into L by pi into E into D1 into D2. So this is the general expression what I am talking about. Since it is for a aluminium bar, so 4 into P into L by pi into Young's modulus of aluminium into D1 into D2, where D1 is the diameter of the bigger one and D2 is the diameter of the smaller one. So this elongation is numerically equal to shortening of the bar because due to the temperature drop. Once the temperature drops from 27 to 0, naturally there will going to be a reduction in the will going to be reduced due to the temperature drop. So there will be a shortening of length. So what is delta L? Delta L is the coefficient of thermal expansion of alpha A into T into L, which is the free expansion. So alpha A into T into L is the delta L value. So that is equal to 4 into P into L by pi E into pi into EA into D1 into D2. So you just LL will get cancels. So what I want is I want P. So tensile load induced on the bar due to temperature drop, which is P, will be equal to LL once gets cancelled, pi into E into pi into EA into alpha A into T into D1 into D2 by 4. Alpha A into T into pi into EA into D1 into D2 by 4. So substitute the value of coefficient of thermal expansion of alpha, which is aluminium, which is 24 into 10 to the power of minus 6 into T is the temperature drop, which is 27 into pi into Young's modulus of aluminium is 0.7 into 10 to the power of 5, and D1 into D2 is 100 into 200. Then we have divided by 4. So on simplification, you will go and get it as 71,251.3 newtons. So, but what is the maximum stress in the bar? Sigma mx will be equal to P by least area of cross section. So what is the load which is coming on that? The load is 71,251.3 is the value divided by pi by 4 into 100 square. Why it is 100 square? Because it is the least area of cross section where you are going to get the maximum value. So that will be equal to 90.72 Newton per mm square. So this is how you will be able to find out the tensile load and also the maximum stress induced in the bar. Thank you.